Hello everyone. In this session we are going to discuss about coordinate systems, and by the time you know that there are three classifications in coordinate system, that is Cartesian coordinate system, cylindrical coordinate system and spherical coordinate system. So Cartesian coordinate system can be two-dimensional, can be three-dimensional. Cylindrical coordinate system has a 2D format that is known as polar coordinate system, and spherical coordinate system is itself three-dimensional. So you already know all these concepts, and you also know that if we think about Cartesian 2D, then we have x-axis and y-axis. X belongs to real number, y belongs to real number. So this is the figure for Cartesian coordinate system in 2 space. Similarly, the polar coordinate looks like this. Here we have r comma theta as the point, and in Cartesian coordinate system 2D we have x comma y as the point. So you can see the difference between Cartesian coordinate system in 2D and polar coordinate system. So now let's look at the coordinate system that are three-dimensional: Cartesian coordinate system, cylindrical coordinate system and spherical coordinate system here. So you can see Cartesian coordinate system is comprising with x-axis, y-axis and z-axis. Cylindrical coordinate system is this one. You need a cylinder here just to locate the position of any point. Similarly, instead of Cartesian coordinate system, we are choosing one sphere. By sphere we will locate the position of any point. So this is the spherical coordinate system, this is the cylindrical coordinate system, and this is the well-known Cartesian coordinate system in 3 dimension. Now we have also discussed all these concepts, that is, in Cartesian coordinate system a point is denoted by x, y, z. In 2 dimension we just need x comma y. Suppose we have the same point, but instead of Cartesian coordinate system we will use cylindrical coordinate system. Then the point will be r, theta and z. Suppose we have the same point, but we are using spherical coordinate system instead of Cartesian coordinate system. So in that case the point will be rho, theta, phi. Rho, theta, phi. So if we think about a point in Cartesian 2D, that is x comma y, then that point can be here also r comma theta, that is the polar form. So if we have Cartesian 3D, then the point is x comma y comma z. Cylindrical 3D, the point is denoted by r comma theta comma z. Spherical 3D, that is rho, theta, phi. So one thing is that this theta is one kind of angle. Here you can see same theta. At the same time we have phi. Phi is another angle, and you can see which angle we are considering. If we have to determine phi, then you have to come from vertical z-axis to the vector. What is this theta? Theta is the angle that is on 2 dimension. Theta is the angle that is on 2 dimension, that is on xy plane. So now we have to know how to convert xyz to r theta z, or xyz to rho theta phi, or the vice versa. That is, you have r theta z, how to convert it to xyz. You have rho theta phi, you are trying to convert it to xyz, or let's say r theta z. So here is the conversion. That is, if we have a point x comma y in Cartesian 2D and we want it to convert to cylindrical 2D, that means it is known as polar, then we need r and theta. for that these formulas will be applied. X equals r cosine theta, y equals r sine theta, and r squared equals x squared plus y squared. That means r equals the square root of x squared plus y squared. Tan theta equals y over x. That means theta will be tan inverse y over x. So these are the cases that are known to you from the last session. At the same time, have a look, here we have z and z. So that means z equals z. We are dealing with the same values of z. So these formulas will be applied to convert a point that is in Cartesian coordinate system to cylindrical coordinate system. Now suppose we have a Cartesian coordinate system and one point is given, that is x, y, z. Then we want it to rho theta phi. So in that case, x equals rho sine phi cosine theta, y equals rho sine phi sine theta, z equals rho cosine phi. You know how we can derive all these things. You can see the figures. You will understand. So at the same time, rho squared is the distance from origin to the point. You can think about this is the norm of the vector or the length of the vector. So rho squared equals x squared plus y squared plus z squared. So rho means square root of x squared plus y squared plus z squared. At the same time, here the formula for finding theta is in the two-dimensional xy plane. So theta will be tan inverse y over x. If we want to measure phi, then we have to use this formula, that is cosine phi equals z over rho. So these are the formulas that we will apply to convert any point to another system. So now there are some restrictions here. You can see there are two angles. If we think about cylindrical coordinate system, we have angle theta that is acting on xy plane. If we are considering spherical coordinate system, then we have two angles, theta and phi. Theta is in xy plane. For phi, at first you have to think about the vector that you have. So suppose you have the vector in spherical coordinate system, and this is the point that you are going to find out in terms of rho theta phi. So what is phi? Phi will be the angle from vertical z-axis, positive z-axis, to the position vector. So phi has also restriction. It can be from 0 degree to 180 degree. You can see from here. Theta is the angle that you see in xy plane. So it can start from 0 degree and it can end at 360 degree. So these are the restrictions for the angles that we are going to deal here. At the same time, r is a distance, rho is the distance. So these two can be with these conditions, that is r greater than or equal to 0, rho is also greater than or equal to 0. So these are the very basic formulas that we have to know first, and you know how to derive all these things. We need to understand the geometry. So we have already discussed all these things in our last session. So here we are going to solve some problems. That means we will convert any point that is in Cartesian coordinate system to cylindrical, or let's say to spherical. So at the same time, we will try to convert any point from cylindrical to, let's say, Cartesian, or from spherical to Cartesian, or let's say from cylindrical to spherical or spherical to cylindrical. So whatever formulas we have seen here are again summarized here for your betterment, so that you can easily look at all these things. Suppose you are converting cylindrical to rectangular, then the formulas are here. From rectangular to cylindrical, the formulas are given here. From spherical to cylindrical, the formulas are here. From cylindrical to spherical, the formulas are given here. From spherical to rectangular, the formulas are here. From rectangular to spherical, the formulas are here. So with these formulas, now we are going to solve some problems. So suppose we have one point. Let's say we have a rectangular point that is in x, y, z form. So it is, let's say, 4, minus 4, 4 root over 6. So what we have to do? We have to convert this rectangular point to, let's say, spherical or let's say cylindrical. So there are two targets that we are taking here. First of all, we have to convert the given point from rectangular to cylindrical. At the same time, what we have to do? We have to convert the same point to spherical. So have a look. The point that we have x, y, z. Now if we have to convert it to cylindrical, then we need r, theta, z. So we have x, y, z, then we can easily convert to r, theta, z. Similarly, for the next problem, we have x, y, z already in our hand, and we have to convert it to spherical. That means we know spherical coordinates are rho, theta, and phi. So remember, theta can be from 0 degree to 360 degree, phi can be from 0 degree to 180 degree. So there are some restrictions on theta and phi. So you know that if we have to convert a point from rectangular to cylindrical, then the formulas are here: x, y, z to r, theta, z. That is, r equals this one, tan theta equals this one, and z equals z. So we have the point here. Now let's convert it to cylindrical. So we are converting the point from rectangular to cylindrical. So the formula is r equals square root of x squared plus y squared. Then you can see, for finding theta, you have tan theta equals y over x, or you can write theta equals tan inverse y over x. At the same time, you know, if we have rectangular coordinate x, y, z, cylindrical coordinate is r, theta, z. So z and z are same thing. So that means z equals z. So we need r, theta, and z. This is r, this is theta, and this is z. So let's now try to find all the values. So here, square root of x squared plus y squared. This is the x value, this is the y value, this is the z value. So let's summarize the information. We have here x equals 4, y equals minus 4, and z equals 4 root over 6. So these are the information that we have from the very beginning. Now let's input x. So x squared plus y squared. So we are getting square root of 16 plus 16. That means we have here r equals square root of 32. So this is r. We have found r. Now let's find theta. So before finding theta, you have to know one concept. Whenever we have learned complex variables, at that time you have seen that theta is known as the argument, and finding theta depends on the location of the point. So here we need x comma y. So if we think about x comma y, then the point is just 4 comma minus 4. Just think about x and y, no need to think about z. That means in 2 dimension the point is in 4th quadrant. So you know that theta has restriction here. Theta can be in between 0 degree to 360 degree. That means theta lies in between 0 degree to 360 degree. So here the point that you can see, it is here, that is 4 comma minus 4, and we have to find this angle. Now let's see from this formula what we get. We may have to correct the result if we don't find the result in this domain. So theta equals tan inverse y over x. So let's now calculate. From here we are getting tan inverse minus 1, and we can write minus tan inverse 1. That means minus 45 degree. So theta has been found minus 45 degree. But we have found minus means clockwise direction. We have found in this direction minus 45 degree, but we need this amount. So that means what we have to do, we have to adjust the angle, otherwise theta will not be in this region. So for that we can just do some simple adjustment, that is from 360 degree we are subtracting 45 degree. That means we have 315 degree. Now any angle should be kept in radian, so that means we know 1 degree equals pi over 180 radian. So 315 degree equals 315 times pi over 180 radian. So you can use your calculator to have a simplified form, that is 7 over 4 pi. So this is theta. So we have found r, we have found theta, and we need z. Z is already here, that is 4 root over 6. So if we collect all this information, then we can say that the point that we have previously, x comma y comma z, has been converted to r, theta, z. So have a look. The point is 4 comma minus 4 comma 4 root over 6. So that has been converted to r, that is root over 32. Theta is 7 pi over 4. Z is the same thing, 4 root over 6. So this is how we can convert any point that is in rectangular or Cartesian coordinate system to cylindrical coordinate system. So one part is done. Now let's solve this one. Suppose we have the same point, but we want to convert it to a spherical coordinate system. So let's do. So for a spherical coordinate system, you can see the formulas. So we will apply the same formulas here. Now we are going to convert the point from rectangular to spherical. So rectangular coordinate system has x, y, z form. Spherical coordinate system has rho, theta and phi. So this is our point that is given. We have now x, y, z. So what will be rho, theta, phi? So we have to find this. So whatever point you can see here, same point is this one, but the system is changed. Previously it is Cartesian, now we are thinking about spherical coordinate system. So for that, have a look. If we have to convert a rectangular point to spherical, then you can see there is a formula for rho, there is a formula for theta, there is a formula for phi. So let's apply these formulas and we will get the result from here. So first of all, have a look, x, y and z. So from here these three information are in our hand. So let's try to find rho, then we will try to find theta, then phi. This is how we will approach. So first of all, rho. So rho means square root of x squared plus y squared plus z squared. Rho is the distance. So here x squared, y squared, z squared. We have plugged the value of x, y and z. X equals 4, y equals -4 and z equals 4 root over 6. So let's now simplify. You can use your calculator directly to get the result. So this time let's use our calculator. We have 4 squared plus -4 squared plus 4 root over 6 squared. So let's see what happens. So we are getting the result of this calculation, that is, it is 8 root over 2. So this is our first value for rho. So rho has been found. Now let's find theta. So here the formula for theta is known to us, that is, we know theta equals tan inverse y over x. So again remember the restriction of theta. Theta lies in between 0 degree to 360 degree. If we are not getting the result in this domain, then we have to adjust. So theta is directly depending on the location of the point in two-dimensional system, not in three dimension. You have to think about just now x and y. So first of all, have a look. If we think just x comma y, so we have 4 comma -4. So the point is in fourth quadrant, 4 comma -4. So that means the angle should be in this direction. So already here we have done the same thing, so no need to do all these things in details. So already we have done all these parts. We have the same angle theta here. So that means, let me show with a short form. So theta equals tan inverse y over x. So that means tan inverse -1. So we will get -45 degree. That means -45 degree is found. So the restriction of theta says that theta should be in between 0 and 360 degree. So that's why we have to adjust. So we have to adjust by this way. We are getting this. So total 360 degree minus 45 degree equals 315 degree. That means this is theta. And we can write or keep the angle in radian form. So already we have done this. So theta equals 7 pi over 4. So we have found rho theta. Now let's find phi. So for phi you have the formula here, that is, you can see cosine phi equals z over square root of x squared plus y squared plus z squared. So instead of square root of x squared plus y squared plus z squared, you know that it is just rho. So we can just write cosine phi equals z divided by rho. This is how we will find phi, the third angle. This is the angle from vertical z-axis to the position vector. So phi equals cosine inverse z divided by rho. So that is what I have written here, that is phi equals cosine inverse z divided by rho. So what is z for our problem? You can see z is 4 root over 6. So cosine inverse 4 root over 6 divided by rho. So rho is already found, that is 8 root over 2. So now we have to simplify this. So remember, phi for this point conversion, phi has restriction. Phi should be in between 0 degree to 180 degree. If we are not getting the angle in this region, then we have to adjust. But remember, there is a shortcut that for theta you may have to adjust, but for phi you will most of the time get the correct result. Okay, so no need to adjust, you will get the result in this region always. So cosine inverse 4 root over 6 divided by 8 root over 2. So let's try to simplify this. So we are getting 30 degree. So we have found 30 degree. Now have a look. The angle that we have found, is it in this region? Is it following the restriction? Yeah, it is going with the condition. So that means the angle that we have found is correct. So finally we can say that the point that we had previously, (4 minus 4 root over 6), now it has been converted to rho theta phi, that is rho is 8 root over 2, theta is 7 pi root over 4, and phi is 30 degree. So you can convert it to radian just by this formula, that is 1 degree equals pi over 180 radian. That means 30 degree. By unitary process you can easily find 30 times pi over 180. So you will get pi over 6. So phi equals pi over 6. That means we are successful to convert a point from x, y, z coordinate to rho, theta and phi coordinate, from Cartesian or rectangular to spherical. So this is how we can do the conversions. Now similarly, let's do another problem. So we have done here conversion from rectangular to cylindrical. Similarly, we can do the conversion from cylindrical to rectangular. So Suppose we have a point in cylindrical coordinate system r, theta and z, that is 4 pi over 3 minus 3. What we have to do? We have to convert this cylindrical coordinate system to Cartesian coordinate system. So convert the given point from cylindrical to Cartesian or rectangular. That means we have r, theta, z given. We have to convert it to x, y, z. So the formulas are known to you. Have a look on the formulas again. If we have a point in cylindrical coordinate system, then we can easily convert it to rectangular. So the formula says that if we have to find x, then x equals r cosine theta. If we have to find y, then y equals r sine theta. If we have to find z, then it is same z. So this is how we can easily find. So first of all, you have to understand what information we have. We have r equals 4, theta equals pi over 3, z equals minus 3. So already the informations are in our hand. R equals 4, theta equals pi over 3, z equals minus 3. So we can easily find now x. So x equals r cosine theta. R is 4, cosine theta is pi by 3. Y, that is r sine theta. R is 4, sine theta is pi over 3. Z equals z. So whatever z you can see minus 3, that is same. So now we have to find the value. So 4 cosine 60 degree. So you can easily find the result here, that is 4 cosine 60 degree, or you can do by this way. Pi over 3 means 180 divided by 3. So the result will be x equals 2. Now similarly find y. So for y we have here 4 sine 180 divided by 3. That means it is 2 root over 3. So this is y. And z is already in our hand. So we can see that the point r theta z, that is 4 comma pi over 3 comma minus 3, has been converted to x comma y comma z. So this is how we can do all the conversions. So now you have the idea, you can solve any problem. So by the same way, let's solve another problem. This time we have a spherical coordinate system. That means a point is in a spherical coordinate that is given. We have rho, theta and phi. So rho equals 4, theta is pi over 3 and phi equals pi over 4. So the point that is given, it is in spherical coordinate system. We have to convert it to Cartesian coordinate system, and for that you can see there is a formula that is from spherical to rectangular. The formula is x equals rho sine phi cosine theta, y equals rho sine phi sine theta, and z equals rho cosine phi. So we just need to input all these values here, that is the value of rho, phi and theta will be plugged, and then we will get the result for x, y and z. So rho sine phi, phi is pi over 4, cosine theta, theta is pi over 3. So we can directly get the result from here using our calculator. We need to find the value of 4 sine pi by 4 means 180 divided by 4 times cosine 180 divided by 3, that is pi by 3. So let's see what is our result. So the result is root over 2. So this is x. X has been found. Similarly, let's find y. So y equals rho sine phi sine theta, that is 4 sine pi divided by 4 sine pi divided by 3, that is rho sine phi sine theta. So we are going to use again our calculator. Instead of cosine we have here sine. Have a look. Rho sine phi sine theta. So the result that we can see, it is root over 6. So y equals root over 6. Now let's find similarly z. Z equals rho cosine phi. So what is phi? Phi equals pi over 4. So that means we can easily find using our calculator this 4 cosine pi over 4 means 180 divided by 4. So the result is 2 root over 2. That means the point is converted to x comma y comma z. So x, y, z is root 2, root 6, 2 root 2. So that means this point 4 comma pi by 3 comma pi by 4, that is in spherical coordinate system, rho theta phi has been converted to x, y, z. So this is how we are dealing with the transformation of points from any coordinate system to another coordinate system. I hope you have understood this one. Now you have to practice. So that's all for today. Thank you.